are in listen-only mode.
Hello, I'm Noreen Klinga, your host for today. Thank you for joining us and welcome to the Innovation That Inspires webinar series. Today's event will feature Joby Aviation, an innovative aerospace startup out of California. Before we get started, just a bit of housekeeping. Other than the presenters, all attendee lines will stay muted during this call. However, if you have a question for our presenters, please feel free to type your question into the Q&A tab on the console. Time permitting, we will address those questions at the end of the presentation. Finally, today's webinar will be recorded, and following the event, we'll send out a link to the replay. And now on to the event. Today's webinar will feature two speakers, Alec Clark, design engineer from Joby Aviation, and Paul Granata, Dassault Systèmes business consultant, aerospace and defense industry. And with that, we are ready to begin. Alec, please go ahead.
Thank you, Noreen. As Noreen mentioned, I'm a design engineer with Joby Aviation, a startup company based out in Santa Cruz, California. After the next slide, please, Noreen. So Joby Aviation, as I mentioned, startup in California. We currently employ about 70 people, majority of whom are engineers. Starting in 2009, we worked on a number of concepts, with a lot of our most recent concepts picking up speed in the last 5 years. Our main mission really is to transform how people get from A to B. And working with NASA and other collaborators on various projects, we've learned a lot about the space, and we've further demonstrated our own concepts internally while working on these collaborative projects. All the while, we've kept up a theme that's been persistent for us, which is called electrical vertical takeoff and landing, or electric VTOL. And in focusing on this allows us to really set ourselves apart from the competition that's in the aerospace market today. Next slide. We hope that with our new technology, we can really press the bounds of how people get from A to B and looking at geographic as well as highway commuting. Currently, over 20 million people commute 45 minutes or more in the U.S. alone. I used to live in Southern California where they had massive billboards that were plastered with, what would you do with an extra 15 minutes? Or what is an extra 15 minutes to you? Ensuring a happy family on the beach. And we've really taken that to heart of how can we enhance people's lives, make their time more efficient by decreasing the time spent in traffic, spent with non-value added time. Nobody likes to do that, and it's not helping us as a society at all. Next slide. So in looking at this, we see that there's a lot of highway traffic. There's geographical barriers that prevent us from getting from our point of departure to our destination. And what we really wanted to challenge was if we could create a new technology, what would that look like? How could we get from our doorstep to our work, get for our commute, go shopping? How can we get over these hurdles? We as a company are really driven and trying to see what that vehicle might look like to break the mold. Next slide. So as I mentioned, we were a small startup company working on a handful of projects. In that time, back in 2014, we were only 15 people. Here's a picture of our shop back then and what our collaborative space looked like. Then for us, it was a matter of looking over at the co-designer next to you and asking a question, and that was collaboration. But we knew that in order to achieve what we wanted to let loose the rest of the market would require much more detailed planning, and that as a company we need to grow a lot. And in order to do so, what tools might we need to grow our company while maintaining our core values that make us innovators in the space and allow us to drive home the mission that we want to do. Next slide. So in the aerospace field, as well as other markets, you see that there's a lot of multidisciplinary projects. And in optimizing a aerospace design, it's a matter of trade-offs. Trade-offs between the mechanical, the analyst team, manufacturing. The better that you understand these trade-offs, the better result you'll have. And so what we wanted to see was what kind of tools we need to mix all these different disciplines together in a way that adds value to the rest of the team and not spend time focusing on details that we don't need. At that time, we were working with a smaller system and using file-based definition, which was very difficult for scalability. It was fine with a couple designers, but we knew that as we would grow, we would need a better way to collaborate on larger data sets. And so that's kind of where we started looking at, well, do we need file management? How do we track these requirements? What does our final goal look like? What do we need for certification? Let's go to the next slide. So once you begin looking into PDM and PLM systems as a small company, you realize that you're at a crossroads for the future of that project, and in many cases, the future of the company. Here we're showing a picture of the Lead Tech project. This was a wing that we designed in conjunction with NASA as a partner and put on the back of a truck and ran down a lake bed to get data. During this project, we were able to get through it with a couple key engineers who drove this process. But we found that we really pushed the bounds of that file-based definition. And this is where we really put a stake in the ground and said, we need to grow past this. We need a better way to manage our files if we're ever to work on larger projects where we need more disciplines to really optimize our designs. And in going down that path, you start looking at, okay, well, once you're organizing all this data, what other information do you want to attach to it? If you have a complex database, what else can you gain out of it? And that's where we started to look at, well, you want to look into manufacturing. You want to get feedback from your designers, from your analysts. And so you really want this all to converge onto one entity within the database. So with tight integrations, we're hoping to come up with a more holistic design that will set us apart in the market. And that once you're controlling part data with a PLM system, what else can you add to the definition of that product? Again, here we're a small company wanting to remain innovative and agile. We don't want to get held up in a burdensome system, giving us features that we don't necessarily need. But we also noticed that in order to remain competitive and to change technology in aerospace, we need the most powerful tools we can get to drive our designs, from simulation through servicing, manufacture, and beyond. Next slide. So one of Joby's strengths is our rapid concept iteration. The ability to pivot from one idea to a totally new and different one has given us the experience across a range of technologies where we can leverage the next configuration. So in making small steps, we can learn a lot about different paths. And it's through those experiences of seemingly unrelated tasks and endeavors that contribute the discipline that we need to make our vehicle be truly revolutionary. We saw that Dassault Systèmes was using a similar method of continuous improvement. When we first came to Dassault, they're industry standard in the aerospace sector, and that's what made us gravitate towards in the beginning. And looking further into their product offering, it is impossible to find an industry that they do not touch. It's actually surprising for us to see a company that, at face value for us as a smaller company, used to smaller CAD systems, we thought that they might be tied to these legacy database of existing industry Goliaths that were putting emphasis, that we now see putting emphasis on redesigning themselves. And they're really seeing how can we improve this interface and their database, and they're not remaining complacent as industries grow around them. They're truly seeing what tools does the industry need to survive, to innovate, and grow. And so for us, that was really the next big thing, and that we're a small company with requirements that echo a very large and, in some cases, slow industry, yet we're a small company that needs to continue to dart around from concept to concept as we find that truly differentiating factor. Next slide, please. So one of the things that we saw that Dassault was working on was the cloud system. And it took us some time to really understand what that would mean to us as a company, and we continue to see benefits from that even today. When we were first looking into the system, the obvious driver was the absence and lack of hired IT. At the time, we were running our own license server for numerous sets of software, and we thought that, hey, we can set up another license server or, set up another database. It can't be that hard. And starting to look into it, we saw that this system, among other competitors, were very involved and would quickly require an IT person that we just were not ready to hire when we were a company of less than 20 people. So we started to look into and really understand what are the trade-offs here with the cloud system. At that point in time, we were still accessing our file-based data through VPN. Working remotely was not really an option, and luckily at that time we weren't needing to. But we were smart enough to know that as we would grow, our employees and our co-collaborators would need to be able to access the same information remotely. So another piece of IT that you need would be a VPN, something where the cloud really helps us access this data from wherever we are. We have employees in Germany, in China, in France, the UK, on the east coast of the United States, on the west coast as well. Everyone is accessing the data, it seems, at any given point in time, 24 hours a day. There's always somebody pulling data from the system. And the fact that data is maintained by itself outside of our hands by the specialists who know the system best really helps us. Well, not even helps us. We don't have to think about that at this point, is how seamless it seems to have been going. So for us, it just comes down to that this portion just works, and minimum back-end support is required from us. Another piece that really helps us go is the tenant sharing. So one piece that we've been working with recently is sharing our database with, again, co-contributors, with suppliers or with fellow designers for surfacing or for manufacturing. We've been using that for machining, for 3D printing, and that ability to grant access to somebody and control their access through just a simple web interface has gone a very long way for us. And rather than just sending non-native information through an email and slicing that chain. Which brings me to the next point of traceability and certification. That's another major driver for us on the PLM and system of how is the information growing, what's its history, and linking as much information as we possibly can to it as far as the design goes, the analysis, as well as how it performs in tests, because that's all going to play a role when we go to get certified. Next slide. So as I mentioned, the industry Goliaths, a lot of them were working on legacy systems, and they're actually tied to a release of software for a project. And those companies have invested a lot of workarounds to get the pieces they need going for systems that are in many cases over a decade old. piece that shines for us at the cloud is we're always on the latest release. I mentioned before tenant sharing. There no longer is syncing up companies based upon which system they're on and which version is that, which hotfix is that. Everyone is on the same system, so sharing data between your fellow workers in the same company, as well as outside of the company, if people on a 3D experience on cloud, you're all on the same release. It's no longer a thought to sync up on. It's merely sharing from a single source. Let's go. Another piece that continues to that we continue to work with now is one of the risks that we saw with the system could be new hires. So with a new system like this, you don't have as large of a base of employees to draw from, or prospective employees to draw from. However, it retains enough of the similar interfaces that existed previously in older versions of CATIA that you can still draw from a very similar pool, and the spool up time is minimized as such. But there are new features that do take some learning. But as a user of both the older systems and the new systems, I'm very happy with where we are. Here in the picture, we're looking at the X-57 Maxwell, the latest X-plane working with from NASA. And on this system, that was, I mentioned before, the legacy systems. Syncing up with employees in a larger corporation was definitely a burden, and making sure that we were exporting the correct formats for everyone to read from the same system instead of just sharing a tenant. So that's a case where a simple shared tenant would have helped 3 different companies all collaborate on the same piece. Next slide. So after we made the decision to move with the on-cloud, what have we been doing since? What has that enabled us to do? From our previous system of really just designing, exporting, losing traceability with information to do our analysis, we're able to now go nearly completely vertical with our concept ideation, through analysis, through design, and out to manufacturing. What really helps us save time here and get faster to our end goal of a prototype and bringing that to market is the native information, that you're no longer severing all this information that you're creating, but you're able to carry that through from one to the next. One example that we typically did in the past was having to run simulation, tweak the simulations, and then take that information back into our design. And getting information back into the design was usually a matter of screenshots or an exported model that wasn't very clean. It required a lot of time to tweak. Now what happens is the designer sets up a nominal state, the analyst goes in and tweaks those parameters and goes back to the designer, and the designer is able then to go straight to manufacturing with minimal inputs moving forward. And I think that alone has saved us much time. I spoke a lot about traceability, or a bit about traceability. That's another component that we are using now of tracking our requirements. And like I said before, we're in a database. Why not tack on that information to the parts? So that's what we're doing. We're bringing requirement information into a database and then pointing that to our references to track the life cycle of that reference, and does it fulfill the requirement that we as a company need to hit in order to be successful. And there are hundreds and thousands of these requirements we must hit. So tracking this can only be done, to me, in my opinion, in a system like this. Past that, we're working with the tenant collaboration with Dassault on any questions that we have about parts. They help us improve our processes, as well as working with outside collaborators. Furthermore, there are integrations that work with FTP and other not SharePoint, but Dropbox and Google Drive. So you can link your other information from other existing databases that you have into this database. And so it's really a holistic result that you get combining all of your data from wherever it may be. And uploading is very simple. And speaking of uploading on these documents, we're working with the document control. Just like with requirements, you need to show the traceability. We have control on the documents that we're making process specs on, making manufacturing specs, quality information. All these pieces that need a history in order to go through certification, we're able to achieve with a database like this. So that's really what we've been doing with the system, which is a lot compared to where we came from. Now we go to the next slide. So last, I'd say, what are we looking forward to? As I mentioned, with the cloud, we have this flexibility. What the cloud enables us to do is, as we grow the company, I almost see it as a wave moving through. You go through the design process. You have more need for design applications and seats and technology. And then as you go through your certification, you have more necessity for administrators. As you pass through that hurdle, you go into more manufacturing. And so this is a system that's able to scale with us, that as we grow, we're scaling up portions that we're growing into, and we're scaling down portions that we don't need in order to, again, avoid non-value-added costs, so that we're not just holding on to seats because we paid for them years ago. We can take that, scale those back and reapply that need somewhere else and those employees somewhere else. So other technologies that we're pushing for here that we see moving forward will be into manufacturing and moving our traceability into that realm, as well as looking into other simulations and doing a full simulation of the aircraft systems and response relative to the feedback in our flight computers. And for us, the more information you can model and simulate, the better the result you'll end up with. So, in conclusion, I would like to end my presentation and hand off now to Paul Granata. Thank you.
And thank you, Alec, and welcome everybody. My name is Paul Granata with Dassault Systems. Up to recently, I was a senior business consultant, and a lot of my work was spent upon helping justify projects like this, and we'll get a little bit into that. Briefly about my background, and then I'll cover the agenda, is I have 20 years experience in the industry working predominantly with aerospace and defense companies, some transportation and mobility companies, and then a third would definitely be with consumer packaged good companies. And then I'll touch also upon where I play when it comes to aerospace and defense in a couple of slides. Today I'll cover a few things. First, some trends and challenges that we're seeing. Some are specific to aerospace and defense or commercial aerospace, but then you'll see that they definitely broadly apply to other industries, especially with some of the disruption that's going on in the industries with Industry 4.0. The need for innovation, I'll cover a little bit about the 3D Experience platform and how it enables innovation. Also, part of this is a decision to have something on-premise or on cloud, and the cloud is a key enabler, and you heard a lot of that already this morning. Critically, where we might talk about some technology, really it's the business outcomes of the technology that are the most important for you all taking your time on the call today, and of course for your end customers. And then lastly, suggestion about how to do an experiment, because we're going to bring up a bit today how quite a few of the programs or quite a few of the products that we've designed have a legacy aspect to them, and how innovation and disruption in Industry 4.0 and the platform kind of frees up an ability to do experiments to see if we can change the business model. So with that, we can go into the next slide. Some of the aerospace trends and challenges that we're seeing, and a lot of this is specifically for commercial aerospace. We're seeing record-setting rate requirements and production requirements. Additionally, we're seeing growing complexity in programs. And then lastly, we're also always seeing the fact that we need spending and pricing pressures. And within this, the first part about rate, there's a tremendous backlog. And that backlog, we believe, is providing a buffer to a lot of companies and that are protecting them a bit from some of this change that's going on in the industry. But when that buffer ends and these legacy programs start to taper off, there's going to be a need to innovate the business model. And we think part of that is speed and more increased collaboration and increased innovation. Second, regarding complexity of programs, we're seeing that as complexity increases, as either yourselves and your requirements upon either your design partners or your suppliers, or if it's a higher OEM or a higher tier of company with their requirements on you, we're seeing that there's a lot more non-value added overhead, and that can be reflected as everybody having up to several hours a day doing IT type administrative functions, such as naming their data, moving into the right folders, cutting and pasting, and before we know it, we're actually becoming an IT system administrator on top of our current job, and that non-value added work can result in us not doing direct work on the critical tasks that we need to be working on, such as innovating our products or our processes. And then lastly, where we get to spending and pricing pressure, in many cases, and probably with quite a few of you on this webinar today, some of you are the low-cost, efficient producer, and you're also providing that low-cost, efficient, and quality product on time. And if that's the case, and knowing that there's these disruptive forces in the marketplace, how do you then find a way to get even better? So with that, we'll dig in a little bit deeper on the next slide. When it comes to Dassault, about 90% plus or minus of the current flying aircraft programs have been designed or incorporate some of our solutions. And that goes from supply chains, of course, critically the OEMs, and where I play, and a little bit more about my experience. I have about 23 years, full and part-time, predominantly part-time in the U.S. military as a Army maintenance officer, and now as an Air Force maintenance officer. And that lets me work in the fixed-base type operations where we'll do maintenance, repair, overhaul, upgrades, scheduled maintenance, unscheduled maintenance, predominantly in that in-service space. So our firm has a lot of experience across the life cycles, from designing through implementation and finding ways to introduce technology enablers that allow that type of innovation across the entire life cycle. If we could just, and I'll be saying next a lot, so I appreciate your, with that, if you take a look, when we look at the OEMs, if you can go back a slide, you'll see that out of all these OEMs, we see how Joby jumps out. And I'm going to be focusing somewhat heavily with some of my opinions on Joby because they are innovating, and they are, as per the topic of this webinar, they're innovating to inspire. Can we go to the next slide? And that ties in well with what we do, because we have an innovation spiral ourselves when it comes to commercial innovation. And the very first thing we're thinking about is dream it. And if you think about the 787, for example, in Boeing, and they said, what is the end customer experience that's going to delight the end customer, and how do we build that type of aircraft and then provide it to the owner-operators? Same thing here. We're seeing that Joby said, let's dream it. And we're going to dig in a little bit deeper in a couple of slides on that dream piece. And then when they dream it, how can they partner with a company, or in our case, an enabling company such as Dassault Systèmes with 35 years of experience in the industry, so that if they can dream it, can they then design it, build it, test it, and sell it, and be profitable, and have the other differentiating characteristics they require to be successful in the marketplace. We'll go to the next slide, please. And I wanted just to make a comment that this isn't just unique to aerospace. Our company works in 12 industries. We're seeing a tremendous amount of disruptive innovation in two of our core industries, the first one being aerospace, and I wanted to point out here also when it comes to electronic vehicles. And it's interesting when we speak about Joby, what industry are they really in? They're in this electronic vertical takeoff and landing vehicle that they're going to have is really disruptive, and it's going to be disruptive to possibly multiple industries and multiple firms within those industries. Next slide, please. And for us, and we can do, it's 2 more builds, please. And for us, it's critical that there's a return on innovation investments. It's no use if a company, if we help create a company or if we're enabling a company and the innovations don't provide a return on their investments, especially the time investment and with the risk involved. So here's a great study from Arthur D. Little, and it's the right enabling that matters, and that's what we're focused on, so that companies can have the right return on investment. And you'll see in a little bit how we link our enabling technologies, in this case the platform, and in some cases very specifically the platform delivered on the cloud, so that there's a return. We're trying to help, in the case if you look on the right-hand side, where over 80% of companies that were interviewed had some sort of unsatisfactory or results when it came to managing their innovation. And even though that there's a clear link through innovation and a higher return on investment and better company results. Next slide, please. So what I did here is at an arm's length, I said, let's take a look at Joby, and let's take a look at the innovation that they're providing and how disruptive it could be to the industry and how beneficial it can be to them. So first, we're going to look at the business drivers. And 2 critical things when it comes to these small OEMs competing in that big space of all those aero OEMs that we saw is time to market. We're seeing that the disruptive small OEMs are much faster than the traditional. The Jobys of the world, and specifically with Joby, if they try to do a 10-year product development cycle, it just wouldn't work. Second, they found a key innovation that's disruptive. In their case, electronic vertical takeoff and landing. That's going to help them meet their objectives. And what are those objectives? Well, this vehicle has to be able to provide some sort of capabilities that are going to differentiate it so that folks are going to want to use it. So we'll use the use case that Alec brought up. You're at San Francisco Airport and you want to get to downtown. So you want it to be fast. It has to be safe, right? Everybody that's calling on aerospace knows that if it's not safe, you can't take off. You have an aircraft on the ground. It has to be affordable, and it has to be certified. If you have those and you're meeting those objectives, you're going to get the benefits of them. And for Joby, it's to revolutionize personal mobility, right? This 2-seater, piece of equipment. It's fantastic. It's going to challenge, all sorts of industries, both aircraft and auto. It's going to challenge companies like Uber and Lyft. It's going to challenge helicopters. It's going to challenge and disrupt so many industries. But what kind of changes had to be done? And if we take a look at some of the changes, they had a break with the past. And this is what's different from the startups versus the established companies, the legacy companies with legacy products. They have the ability to break silos within and external to the firm. They're not set in ways that it might have been set up policies and procedures 10, 15 years ago, or that have been mandated upon them. They're able to innovate around those. Additionally, they can get involved with suppliers or other design partners anywhere in the globe, like was mentioned earlier, and they can build stronger relationships with them. And that goes across the life cycle, even though in their case they're still early. They need these types of business changes, and this is where we tie in with some enabling changes. First, and it was brought up, tenant licensing. So now not are you working, you're not working asynchronously, emailing things or dropping things into a Dropbox or an FTP site. You're having them work side by side with you at a high level of collaboration anywhere in the world, right? With the right amount of access, the right amount of controls. And you're able to do multidisciplinary work. So true collaboration occurs, true concurrency occurs. And you're taking advantage of cloud-based deployments, which we can dig in deeper a little bit later, but those cloud-based deployments let you deploy quickly, administer easily. And all of a sudden, like I brought up early, which was more and more of our jobs are taking on this IT administration component, we're removing that. And we're letting people focus directly on their value add and less on that overhead. So all of a sudden, total cost of ownership for the solution starts to drop. And that starts to free up time and capital, which lets them feed back into the innovation engine. And then we have some specific enablers. And you can see, and I kind of commented on some of this, fast rollout. In some cases, the technical portion of the fast rollout is 5 to 20 minutes, where you go from getting an email, you create your account, you log in, you access a dashboard, which is fantastic, you select what you're going to work on, and you download. More direct time on task, like we talked about, integrating design and simulation. And then you can add in additional domains, certification, requirements management, tracing of those requirements, passing that down into manufacturing. So that's where you start to get more and more innovation because you're connecting more and more groups, and that's where the need eventually for a platform comes in. And that's what we're eventually getting at. And we can go to the next slide. Oh, before we go to the next slide, one more comment, because I wanted just to tie back into that commercial innovation, commercial aerospace innovation model that we have, and that desire or that dream to dream big. This is an incredibly big dream on the Joby part, and if they fulfill this, it's going to be fantastic. But to end up having a solution that's going to require 5 times less energy than conventional auto transport and 5 times the door-to-door speed. If you can do that, you are highly innovative and highly disruptive, and they're doing this in the blending of 2 core industries where the incumbents just do not have the ability to do this type of work right now. Next slide. So part of innovation to us is connecting communities, and we can let this build a little bit more. There's 2 more, thank you. Because innovation could come from anywhere, and it's from the customer, it's connecting in the suppliers, it's the business communities, and of course we're really strong and we're very familiar with the technical communities, and this is where a platform approach and a platform thinking, especially when it's coupled with the cloud, lets us retool our own thinking so that legacy way of thinking of silos and handoffs, that goes away, and we get the speed and the power of collaboration by connecting these multiple communities to get that innovative, disruptive results. Next slide, please. Because underneath we understand that what's critical, it's the people. And the people these days, and I didn't get too much into the aging workforce, but the people these days are all around the globe. And they're in all those different domains that we talked about, from business to technical communities to supplier communities, all the way to the customer. And we need a way to get all that and then be able to, in the right way, anytime, anywhere, tap all those capabilities and tap the time, talent, and energy of our folks or the extended enterprises anywhere in the globe. Next slide. And we're doing that with our 3D experience platform. And we talked about how it's designed for cloud and the benefit of the cloud. Alec kind of brought up a simplified interface. This way we don't have multiple people trying to go to multiple different applications and trying to figure out what they do, because all that's non-value add. We want to get the dashboarding right away, because we saw earlier that 80% of companies aren't necessarily happy with their innovation return on investment. We need to find a way to help them collaborate, keep it loose and keep it flexible and agile, but we still want to be able to measure it, because these projects have to have a business outcome. We want to extend to any discipline, and that's the benefit of a platform. The platform breaks down silos. It lets us plug in legal. It lets us plug in marketing. It lets us plug in someone with just some crazy ideas that we just might want to pay some attention to, and in a way that's controlled. It's to take advantage of all that social collaboration. The main benefit is to get that innovation that we're talking about for the product, the process, or whatever we need to work on. At the same time, we want to get this secondary benefit, and it's almost a secondary benefit that comes for free. We want to remove all that non-value added time. We want to help increase capacity. We want to take advantage of the cloud so that we can reduce the total cost of ownership. So now we're not worried about software and middleware, or I should say we're less worried about software and middleware and the operations and the administrative support, the physical environment, right? Securing the physical environment, the physical hardware. We're getting our focus back on where it needs to be, which is our direct jobs and on innovating our products so that they're differentiated and disruptive in the marketplace, and that's what we're focused on. And that lets us free up capital. And if that capital that we free up then gets, again, pushed back into our innovation engine. Next slide, please. So in my summary, when I think about what we could do in enabling innovation, I'm thinking in the terms of experiments. So I come again from an industry, aerospace, where taking risk is a bad thing. Risk is bad, and we do everything we can to remove risk from every process and in everything we do. Conversely, we always want to grow and make every process and everything we do better, so we use the term experiments. Right now, I see that the external business driver for us to do experiments on platform thinking, on getting innovation back into our businesses is to an experiment. The competition's there. Some of us might be shielded from it a little bit because of lengthy contracts, but the competition's there, and those legacy, at some point when these legacy projects dry up or finish, we're going to have to retool at that point anyway. Legacy business is being done at legacy product development speeds. And even though those might be very fast, and I know it because I do a lot of work in aerospace and defense tooling, it's still based on a different type of process. It's more stage gate. That speed's too slow. We find that it consumes schedule, and that capacity sometimes sits idle, which is just a non-value added way to consume capacity, and it can be reactive. Contrasting that, we're looking at all the disruptive companies that we're working with, such as Joby and Aero, but also when we look at our electronic vehicle companies and auto, battery providers, interconnect technology providers. That I almost liken it, or I almost call it Silicon Valley speed versus legacy speed that we might see with some other areas that just don't have that kind of speed that we're used to. It's legacy speed versus the new speed of business. I kind of talked a little bit about how the platform kind of offers that speed, that controlled collaboration, and so forth. So my kind of overall thought is that proactively for us to engage and look at, based on business drivers, which is always critical, how do we carve out a platform-based experiment with anybody that's attending and wall off your legacy environment. We don't want to disrupt. You could be generating millions to hundreds of millions of dollars of revenue through your existing products. How do we carve out some space to do some experiments around getting more speed and maybe innovate the business model with you all? So with that, I'm going to conclude and turn it back over to Noreen.
Okay, thank you, Paul.
Thank you.
Just a quick reminder, as we're waiting for more questions to come in, just type them in your panel. But during the presentation, we received a few. This one is for Alec. Can you speak a little bit more to the cloud? Is it really there? Does it work? And the speed of working on the cloud?
Absolutely. So when we first started working with the cloud, it was really in its infancy, and we were nearly on a beta system. And at that point in time, it was working for the bare bones, and it was a good offset for what we were trying to change. Over the years, we've seen it mature an immense amount. As the servers have been deployed throughout the world, our speeds have gotten faster and faster. Now it's really down to how fast an internet connection do we have. and that's what dictates how fast our data comes down. And as far as the tools go, every hotfix has been new tools coming out. But previously, the choice was between on-cloud and on-premise. On-premise had the full suite of existing tools, and on-cloud had a percentage of that. And it's now gotten to the point where I think the rollouts are happening almost simultaneously. So all the new and greatest pieces that happen for, let's say, an advanced technology like carbon fiber and composites, we have all the latest releases of those modules. So I think it really is there. And for a company like us, a company our size or even larger at this point, I think they can be successful with the tools that are currently available and the workflows that exist.
Okay, great. Thank you. Paul, this is a follow-up for you to that question. Can you speak to the security of the cloud?
Sure. I'll make two comments. The first one would just be about cloud and is it really there? I'll put the quotations in really there. What's critical, my recommendation would be is what are you looking for, right? And in some cases, there might be everything you need and more in the cloud. Let's find out what really there really means. And that comes down again to what's those requirements, right? What's those technology enablers that you're looking in the cloud, one. And then two, what's the additional benefit of the cloud? And then now let me jump into three, which would be about security. So the first is, and I think we'll put this out, hopefully we'll put this out, which is right on our website, we have a security in depth white paper. And there's actually, I think there's two out there. Because it's going to go through the fact that in some cases, well, in all cases, we're going from the physical security, where physically that data is secured, the virtual systems, we go through the application security level, the cloud security level, and of course the internet itself, HTTPS and so forth. So we go through the multiple layers of security, so security in depth. And then there's also overviews of the proven technologies of the cloud providers that we work with. So not, application and the infrastructure. So when it comes to cloud and how it's secure, you're going to hear answers from it's more secure than the way we're doing it now, because we don't often hear about cloud security providers being hacked versus major corporations quite often being hacked, right? I then go back to the quotation marks, which is what's our security requirements? And then let's match them line by line. And if you go online and you do searches and for example, if you look at the U.S. government, they're even putting, well, their data is already online and you're seeing more and more of it being put online. It's just, let's make sure that it meets the customer's security requirements on top of the fact, which might end up being a subset of our overall security capabilities. So I hope that gives you a good answer. I always come down to it's the requirements. We have a couple of papers up there already, and it's just that the best answer is sometimes I hear, well, we deal with this, so we can't put our information up there. In some cases, that information is already up there. There's already standards for how it can be properly published.
Okay, great. Thank you, Paul.
Yep.
Another question for you. Can you share other examples of how Dassault Systèmes enables industry-wide disruption?
Oh, well, so that's just a great question. That's just a great question. Is somebody who asked that, is there any additional depth to that question, such as, do you want me to focus on a specific industry?
I don't have that information, but we'll wait for it to come in.
Yeah, maybe that'll come in.
Okay. Well, while we're waiting for that, here's a question. Both of you mentioned 3D experience. What exactly does that mean to each of you?
Alec, would you like to go first, and I can take a second?
Sure. William, can you repeat the question?
Sure. Both of you mentioned during your presentations 3D experience. What exactly does that mean in terms of your company?
So 3D Experience, for those of you who may not be familiar with the branding here, is the title of the holistic system that Dassault offers, that we kind of refer to as on cloud. It encompasses CATIA, which is normally the CAD or the computer-based definition of models. And it brings together many other aspects, social and collaborative, simulation and manufacturing, as well as accounting or even project management. And so what that means to me is really the product life cycle as a whole, looking for taking a product from the first bit all the way through manufacturing and tying together all that data. So 3D Experience is everyone's tying together your company's experiences with the product through its conceptual design.
Yeah, and so for me, if you think about our company, and this ties a little bit into the earlier question about how we disrupt industries. 35 years that Dassault has been in existence, right? They disrupt industries with 3D modeling, and then they disrupt industries with mock-up, right? And 3D modeling took us off the drafting board. Mock-ups took us from physical mock-ups to virtual mock-ups to eventually simulating the entire environment, right? Then it took us to PLM or PDM and PLM, and then we eventually moved to what we consider the 3D Experience platform. This ties a little bit into my slide where the platform breaks with what we think about. And when you think about PDM and PLM, the platform is a business platform. Our entire discussion today hasn't been about modeling better or manufacturing better. It's been about how to innovate better and how to get speed. And part of getting speed and innovating better is creating better customer experiences. So the 3D Experience platform for us is breaking down all those silos. And we bump into this a lot, where we have customers that will make siloed-based decisions and think that they can sew them all back together to help get profitability or help get revenue growth or help reduce cost. And then they sub-optimize any of those outcomes. The platform lets us tie in multiple communities internally and externally against some sort of business objective that's bigger than what we traditionally might think about. There is a legacy to this company about thinking in terms of CAD models or in engineering. This is much bigger than that. This is about creating better business experiences and tying in all those other communities like we talked about, the customer community, the supplier community, the business and the technical community, just directed towards a business outcome. That's the platform, and that platform has to give the business outcomes and have those underlying technology capabilities and those technology capabilities have to result in being technology enablers for business change. That's what we're focused on with the platform.
And I would just like to add to both of those answers that through our webinar series, which we're entitling Innovation That Inspires, we hope to bring more stories of the kind of customer innovation and disruption that both Paul and Alec talked about. So I think that about does that for our time today. If we didn't get to your question, we'll follow up after the event. I'd like to thank Alec and Paul for their time. Great presentations. Attendees, thank you for joining, and keep a lookout, as I said, for our next session of this Innovation That Inspires webinar series. Details coming soon. Thank you.